or triangle centers. Okay. So when we look at this, we have 4 different kinds, and you know what? I changed the order here after I printed yours. Do you see how yours isn't in the same order?
Yeah.
Okay, but it's the same stuff. It's all the same stuff, just mixed up a little bit. And the reason I did is because I have this great mnemonic that's over there on the other side of the board. Okay, and the mnemonic goes like this. All of, so A and O stand for altitude and orthocenter. My children, and I actually refer to all of you as my children.
For students.
No, I will say students, but you're my children. And so my children refers to median and centroid are bringing in. Now this isn't going to work for y'all because it doesn't go down in the right order, does it? And so this stands for angle bisector and in-center. Peanut butter cookies, which we can't really do because too many people have peanut butter allergies. Okay, so perpendicular, bisector gives us the circumcenter. So it goes like this. All of my children are bringing in peanut butter. Uh-oh, I ran out of space. Cookies. Okay, so what are these things? What is the orthocenter, the centroid, the in-center, and the circumcenter? They're centers of triangles that we find different ways. The orthocenter can be found by using the altitudes. What's another name for altitude, guys?
Oh.
Climax.
When we talked about, yes, height. Altitude, the triangle is the same as the height. So an altitude is just perpendicular from one vertex to the opposite side. Perpendicular from a vertex to the opposite side. So if we were going to construct that, that's where you're going to do perpendicular to a line through a point off the line. We practiced that the other day, didn't we?
We have.
Good thing, good thing. All right, now the cool thing about the orthocenter is when we have an acute triangle, the orthocenter actually lies inside the triangle. But if we had an obtuse triangle, the orthocenter would be outside the triangle. And if we had a right triangle, the orthocenter would be on the vertex of the triangle. And I think I have these done on GeoSketchpad. I'll probably show you that at the beginning of the video tomorrow. Medians. A median is a segment that goes from a vertex to the midpoint of the opposite side. That's what a median does. It goes from a vertex to the midpoint of the opposite side. All right, can we find the midpoint of a segment?
Yes, we can.
Sure. What do we use to find the midpoint of a segment?
Coordinates.
Okay, so we do know how to do it if given coordinates, but if we were constructing it.
Compass. Yes. Bisectors.
Perpendicular bisector gives us the midpoint,
bisector,
doesn't it?
bisector.
Now we wouldn't have to draw in the whole perpendicular bisector. Just put the little part where it passes, and then you would go from the vertex over to here. We wouldn't draw in the whole thing. Okay, now the cool thing about the centroid, the rest of them have neat things that have to do with distance. The neat thing about the centroid is the distance from the vertex of a centroid, from the vertex to the centroid, it's twice the distance from the centroid to the side. So whatever this is right here, this is twice that. So if from A to the center was 10, then from the centroid to the side would just be 5. It's in a 2-to-1 ratio. Okay, the next one, in-center. In-center is cool to me for a couple reasons. One, it's formed by angle bisectors, and they're pretty easy to construct. We do the big arc, and then shift, and then little arc, pass through. Okay, so it's formed by the angle bisectors. Now, when we do the angle bisectors and they give us this point, do you see that we can actually draw an inscribed circle inside the triangle?
Yes.
In center, inscribed. Now, if I found the radius from here to here, and from here to here, and from here to here, wouldn't it be the same?
Yes.
Well, the neat thing about the in-center is it's a point that is equidistant to all the sides of the triangle. It's equidistant from here to here, from here to here, and from there to there. So that's the neat thing about the in-center. We get an inscribed circle, and that in-center, that point there, is equidistant to all of the sides. Now the last one, the circumcenter, we can see that we can circumscribe the circle about the triangle. And the circumcenter is formed using the perpendicular bisectors. We are champs at constructing with perpendicular bisectors. So here's a picture. We see how we have the perpendicular bisectors at the sides. And with this, if we drew in this distance to all the vertices, it is the same. So a circle can be circumscribed about the circumcenter. And that means it is equidistant to all the vertices. Okay? Questions about that? All right, I'm going to quit recording now because we're going to spend the rest of class working on our constructions. I passed out a sheet of paper that has Crazy Town, Lazy Town, and Busy Town. And it has 4 different scenarios. And it tells us what it wants us to use. It wants us to use altitudes on one of them, medians on one of them, angle bisectors on one of them, and perpendicular bisectors on one of them. So what are we creating? We're finding the orthocenter, centroid, in-center, and circumcenter. Okay? The homework, for those of you that are watching the video, is posted to the website. It's on the calendar. And if you were out today, you can actually pick up the worksheet in class tomorrow. It'll be in the makeup folder.